Let's start with number 19. So we will square each of its digit and then add them. So see, 19, the digits are 1 and 9. We'll square the digits and add them. So 1 square is 1 and 9 square is 81. So we got 82. Now we'll square the digits of 82. So 8 square plus 2 square. So 8 square is 64 plus 2 square is 4. So we'll get 68. Now we'll square the digits of 68. 6 square plus 8 square. Now 6 square is 36 plus 8 square is 64, and after adding it we'll get 100. Now what we'll do? Now 1 square plus 0 square plus 0 square. We got 1 square is 1, 0 square and 0 square is same. So eventually we got 1. Since we have reached 1, 19 is called the happy number. So 19 is a happy number. Now let's take another example, 7. So 7 square is 49. Now 4 square plus 9 square, we will also square the digits of 49. So 4 square plus 9 square. Now 4 square is 16 plus 9 square is 81. So after adding it we will get 97. Okay. Now 9 square plus 7 square. So 9 square is 81. 7 square is 49. So after adding 81 plus 49 we'll get 130. Now we'll square the digit sums of 130. 1 square plus 3 square plus 0 square. So 1 square is 1, 3 square is 9 and 0 square is 0. So 9 plus 1, 10, we'll get 10. Now what we'll do? 1 square plus 0 square. See, again we reached 1. So 7 also eventually reached 1. So 7 is also a happy number. Now let's take one more example, that is 13. So 1 square plus 3 square. 1 square is 1, 3 square is 9. So we got 10. Now 10 square, 1 square plus 0 square. Eventually we reached 1. So 13 is also a happy number. So we can say that after repeating the same process, if we eventually reaches to 1, so the number is a happy number. But what happens when the number does not reach 1? Let's take an example. So let's take an example of 4. So 4 square is 16. So 1 square plus 6 square is 1 square is 1, 6 square is 36, so we'll get 37. Now 3 square plus 7 square, we get 3 square is 9, 7 square is 49. So 49 plus 9, it is 58. Now 5 square plus 8 square. So 5 square is 25 plus 8 square is 64. So after adding 25 plus 64 will get 89. Now 8 square plus 9 square. So 8 square is 8 8s are 64 plus 9 square is 8 9 9s are 81. So after adding these number we'll get 4 plus 1 5, we'll get 145. Now we'll do 1 square plus 4 square plus 5 square, 1 square plus 4 square plus 5 square. So 1 square is 1, 4 square is 16, 5 square is 25. So after adding these numbers, we'll get 42. Now we'll do 4 square plus 2 square. So 4 square plus 2 square will get 20. Now we'll do 2 square plus 0 square. So we'll do 2 square plus 0 square. 2 square is 4 plus 0 will get 4. So you can see we started with 4, and after repeatedly squaring and adding the digits, we eventually reach to 20. You can see. But 20 again took us back to 4. And now we are back to where we started. This process will continue forever in this cycle, and we will never reach 1. Therefore, 4 is an unhappy number. Let's take another example, 12. So now we are taking example of number 12. So 1 square plus 2 square. So 1 square is 1, 2 square is 4, so we'll get 5. Now 5 square is 25. Now 2 square plus 5 square will get 2 square is 4. 5 square is 25, so 25 plus 4 is 29. Now 2 square plus 9 square. So 2 square is 4, 9 square is 81, so we'll get 85. Now 8 square plus 5 square. So 8 square is 64. 5 square is 25. So we'll get 89. Now 8 square plus 9 square. 8 square is 64. 9 square is 81. So we'll get, after adding 64 and 81, 4 plus 1, 5. So 14. So we'll get 145. Now again 1 square plus 4 square plus 5 square will get 42. Now again 4 square plus 2 square. So 4 square is 16. 2 square is 4. So we'll get 20. Now again, if you remember something, so 2 square plus 0 square, we reach to 4. Notice something important. We didn't start with 4 this time. We started with number 12. You can see we started with number 12. But eventually 12 also entered the same cycle beginning with 4. Therefore 12 is also unhappy number. Simple rule, surprising behavior. Happy numbers are simple but beautiful examples of iteration in mathematics. We repeatedly apply the same operations and observe whether the number reaches a fixed point or enters a cycle. They are also useful for introducing ideas such as sequence cycles, algorithms, and cycle detection in computer science. So now homework for you. Check if these eventually reaches 1 or enters the 4 cycle. Don't just calculate it, comment your answers below. Meet you in the next lecture. Keep learning. Thank you so much.